You know, video game controllers, they're kind of like our magic wands, right? They're our starship helms, our gateway to all these incredible digital worlds. We spend hours and hours with them, but we hardly ever stop to think about the insane precision engineering that's packed inside. So let's do that. Let's dive in and see what really makes these things tick.
So this whole explainer, it's basically a mystery, and it all revolves around this one tiny, delicate metal disc. We're going to find out exactly where it's hidden inside the controller, and way more importantly, what it does that makes pretty much every modern video game even possible.
All right, to solve this mystery, we first need to know the lay of the land. So we're going to go on a grand tour of a PlayStation 4 DualShock controller, taking it apart piece by piece. Keep your eyes peeled and see if you can guess where our little mystery disc might be hiding. So once we pop the hood, this is what we're looking at. You've got the outer shell, of course, a mid-frame that holds everything together, the circuit boards, rubbery gaskets, a touchpad, and yeah, the vibration motors and the battery. I mean, it's a lot of stuff, but it's all organized with this incredible efficiency. Okay, now let's zoom in on the heart of the whole operation, the main printed circuit board, or PCB. This is where the real magic happens. We've got the microcontroller, that's the brains of the controller. We've got chips for wireless and for motion sensing, and right there, soldered straight onto the board, are the analog joysticks. So, have you spotted our little metal disc yet? Okay, let's make this mystery a little deeper with a hint. We're not just looking for one of them. Nope, there are actually four. Four of these supercritical components are hidden somewhere inside this controller. All right, let's take our first deep dive and check out how the buttons work. I mean, you press them thousands of times, but how does that physical push actually become an action on the screen? Well, the answer is surprisingly simple and kind of beautiful. Okay, so here's the crucial part. Under every single button, there's a tiny gap in an electrical circuit. When you press down, a small conductive pad on a rubber gasket literally acts like a bridge, closing that gap and letting electricity flow through. It's basically a really fancy on switch. And when you let go, the bridge lifts, the circuit breaks. Simple, effective, and honestly, brilliant. But you know, not all buttons are created equal. The face buttons, your X, your circle, they're simple on or off switches. But the triggers, L2 and R2, they're totally different. They need to know how much you're pressing them, like when you're gently tapping the gas in a racing game. For that, they use a pressure-sensitive resistor, which actually measures the force you apply and sends a variable signal, not just a simple on. Okay, now we are getting so much closer to our mystery. Let's talk about the analog sticks. This is where the controller goes beyond just simple commands and into that smooth 360-degree control. This is the precision engine of modern gaming, right here. Let's look at the pure mechanics going on here. When you push the joystick, you're not actually touching an electrical component directly. No. Instead, you're moving these two little plastic brackets called followers, and their only job is to convert your push, in any direction, into two separate, tiny rotational movements. And what measures that rotation? This little component right here, a potentiometer. Now, the name sounds super complex, but the idea behind it is really simple. It's an electrical component that turns a physical rotation into a measurable change in electricity. Just think of a volume knob on a stereo. The more you turn it, the more the signal changes. Same idea. And that brings us to the climax of our whole investigation. Those followers, they're turning a potentiometer. So what's inside that potentiometer that lets it measure rotation so precisely? Well, it's finally time to solve our mystery. Okay, this is where it all connects back to that hint I gave you. Remember the four mystery discs? Well, there are two potentiometers for each analog stick. One for the X-axis, one for the Y-axis. That makes four in total. We are just about to crack one of these open. Any final guesses on what's inside? And there it is. Voila! Inside the potentiometer, we find our small metal disc. Its technical name is the wiper. It's been hiding in plain sight this whole time, quietly doing one of the most important jobs in the entire controller. So how does it work? This is just a brilliant illustration of a basic electrical principle. The wiper sweeps across this circular track made of a material that resists electricity. Now, the farther the electricity has to travel along that track, the higher the resistance gets. By reading that tiny change in resistance, the controller's brain knows the exact rotational position of the wiper, and therefore the exact position of your thumb. And that is why the wiper is so critical. It's the translator. It's the thing that turns your physical movement into a digital signal. The difference between a stealthy creep, a gentle walk, and a full-on sprint in a game? It all comes down to the precise position of this tiny metal wiper on its little resistive track. And this is not just a PlayStation thing. Oh no. This fundamental concept, a wiper inside a potentiometer, is the engineering standard for analog sticks. You'll find a really similar setup in Xbox controllers, the Nintendo Switch, Joy-Cons, you name it. It is just the elegant solution to the problem of precise analog control. So the next time you pick up a controller, maybe you'll think about those 4 tiny wipers, translating your every single move. It really makes you wonder, doesn't it? If a game controller is this packed with clever engineering, how many other simple devices that we take for granted are hiding their own secret worlds of precision engineering?